Hello, and welcome to Astronomy 100. In this section of the course, we're exploring the origins of understanding. This is the section where we describe how the ancient people of the Earth were able to figure out some of the more basic concepts related to astronomy, things that today we take for granted, but were very difficult to figure out for the very first time. And last time we were together, we talked about how the ancient Greeks were confused about whether or not the Earth was a moving body. They wanted to know if the Earth was something that was spinning or if the Earth was something that was moving through space. And so they did a few tests to try to figure out the answers to those questions. And unfortunately, what they came to the conclusion of was that the Earth was not a moving body. They believed that the Earth had no spin to it. They believed that the Earth was not physically moving through space. And this leads them to a concept of understanding called geocentric cosmology. And if you remember, geocentric means Earth-centered. And when you combine this mistaken belief that the Earth is not spinning on its axis nor moving through space, with the observation of all the objects that move across the sky, the sun, the moon, the planets, the stars, it creates the illusion that everything seems to be moving around the Earth, and therefore the Earth must be at the center of the universe. In today's section, what I'm going to do is I'm going to walk you through how this misunderstanding, this unfortunate belief about the stationary Earth would affect how the ancient Greeks understood the universe around them, and unfortunately leads them further and further down this very incorrect and difficult path. In this first picture I want to show you here today, this is the geocentric cosmology as understood by the ancient Greeks. And again, the era of this picture would be about 2,200, 2,300 years ago perhaps. What you can see is at the center of this illustration is the Earth, hence the term geocentric or Earth-centered. There was a realm of water that surrounded the Earth in their minds, and of course today we could say those are the oceans. They believed in the realm of air, which again today we would consider to be the atmosphere. And then unfortunately, they mistakenly believed that there was a realm of fire, that all fire comes from and is trying to go back to. And it leads to some mythology that's related to fire. But of course, today we know there is no realm of fire. Now, surrounding the Earth is the revolution of the Moon in its orbit around the Earth, and they did get that correct. That's something that is observed and turns out to be true. Then they have the movement of the object Mercury around the Earth, and then they have Venus moving around the Earth. And then in between Venus and Mars is the Sun. You'll notice the Sun's placement would be here, then Mars, then Jupiter, and then Saturn. So all of these bodies were bodies that were observed to move in a way through the sky that was different than the stars. The edge of the universe would have been the celestial sphere, and we talked about that in a previous section. And beyond the celestial sphere was essentially the unknown portion of our existence, our universe, the realm of the gods, perhaps. Now, you'll notice that these 5 objects, Mercury, Venus, Mars, Jupiter, and Saturn, are in their correct order. In our universe that we understand today, Mercury does come first, closest to the Sun, then Venus, then, of course, we have the Earth here, but they mistakenly believed the Sun and the Earth were reversed. But then Mars, and then Jupiter, and then Saturn. All 5 of these bodies are in the correct order. Unfortunately, they believed, back in the time of the ancient Greeks, that they were closest to the Earth in increasing distance. So Mercury closest to the Earth, then Venus, then Mars, Jupiter, and Saturn. So how did they get this to be correct? How did they figure out these 5 bodies in the correct order? It clearly can't just be chance or luck. What they did was they employed a little bit of logic that turns out to be correct. If you watch the moon on a nightly basis, the moon moves around the Earth in a period of about a month. And the next fastest object that you would see move across the sky is Mercury. Mercury appears to move all the way across the sky and around back to its starting point in about 88 days. Venus takes 243 days, Mars takes 687 days, Jupiter takes almost 12 years, and Saturn takes almost 30 years, takes a little more than 29 years. So in the minds of the ancient Greeks, they ranked these 5 bodies in the order that they did based on speed. The fastest moving body must be the closest to us, and then next the slower and slower until you get to the slowest body, which must be the furthest. That logic turns out to be correct. Unfortunately, it is not closest to the Earth in their minds. In reality, it's closest to the Sun. So Mercury is closest to the Sun, and then Venus, and then eventually we get to Mars, Jupiter, and Saturn. So they were able to do some things correctly and use some logic in their day that turns out to be correct even in our day. Now, how does all of this geocentric cosmology affect how they observe the movements of these 5 objects as you see them in the sky? So what I'm going to show you is an animation of how you would perceive the movement of any one of these 5 objects in the sky. And what you'll notice in this animation here is this is the animated movement of Mars. What you're looking at is the equivalent of going outside night after night after night, taking a picture of Mars as you see it against the background sky, and then putting all those pictures together as one complete sequence. And for reference, the constellation in the background there is the constellation of Sagittarius. What I want you to notice is the stars of Sagittarius all stay together. But Mars looks like a star. Unfortunately, it seems to be doing something a little bit different and difficult to explain. So Mars moving night after night after night against the background stars would do something quite like this. You notice that when the sequence begins, Mars is moving in one direction, then it appears to slow down in reverse direction, and then moves in backwards for a while, and then it reverses direction and goes forwards again. This looks a little crazy. It looks as if something that you might not want to believe based on what you're seeing in this animation. But what I'm going to show you is a picture of this actual thing happening. In this picture here, you can see that it is a composite set of photographs, again, of Mars. And what you'll notice is each one of these dots is a photograph of Mars taken over a lengthy period of time, over a series of weeks or months. And you can see that night after night after night, Mars moves in one direction, and then it reverses direction for a period of time, and then it reverses direction once again and starts to go forwards. So this is something that you could actually go outside and see should you take the time and make the effort to see this. So this forwards and forwards movement was very confusing to the ancient Greeks. And to try to explain this movement, they first came up with a word to describe the objects that do this wandering movement. And the word that they came up with in Greek, shown here, if we actually translate it into English, would be the word planetos. Today we actually truncate the word to planet. So planetos is the Greek word that translates into the word wanderers. In the ancient Greek world, these 5 wandering stars were different than the rest of the stars because of how they appeared to move against the background sky. Today, we would say the word planet Mars because it is a world or someplace very similar to the Earth. The worlds of our solar system, the planets of our solar system are places we can go to, places that are similar to the Earth. But in the ancient Greek world, the word planet simply meant wandering stars. You'll notice in this picture that when we look at actual stars and compare it to Mars, it does indeed look like a star that just appears to wander. So this forwards, backwards, forwards movement was confusing to the Greeks because it did indeed look like 5 stars appeared to wander against the background sky. So how do they explain this wandering movement, and how does it relate to the Earth being the center of all things? First of all, let's talk about the terminology that we're going to use. And in this next slide, I'll show you the terms that we use to describe this. In this illustration here, again, it's meant to be Mars moving against the background sky. When a planet moves across the sky, night after night after night, it typically goes from the direction of west towards east. So you'll notice the arrow down here, west is off to the right, east, the direction of east, is off to the left. And we call this normal movement, we call it direct motion. And again, it's west towards east. When the planet appears to slow down and reverse direction, this reversed direction movement is called retrograde motion. Retrograde means backwards, so backwards movement or retrograde motion. And then when the planet slows down and reverses its direction one more time and goes back to its original direct motion. If the planet appears to make a loop, such as you see in this illustration here, we call that a retrograde loop. So the retrograde loop is what a planet occasionally does, and you might hear an astronomer say, Mars is in the middle of its retrograde loop right now. How do the ancient Greeks explain this? Well, let me show you the first person. Let's talk about the first attempt to explain this sort of confusing forwards, backwards, forwards movement. Aristotle was a Greek philosopher who lived about 2,400 years ago, and he was the first person to offer an explanation to describe this confusing forwards and forwards movement. So let me show you his model that he comes up with to try to match what you see in the sky here. The model has multiple components to it. So let me start off with describing how you'll notice that the Earth is the center of the universe. So here is our geocentric cosmology. In the mind of Aristotle, in his creation here, the planets were attached to a circle, a small circle called an epicycle. So this small circle is the epicycle, and you can see the planet is attached to it. The center of the epicycle is attached to a larger circle called a deferent. And so the epicycle turns, but it's attached to the deferent, and the deferent also turns with the Earth at its center. When we combine the movement of the planet on the epicycle while turning on the deferent, we get this. And what you'll notice is this mechanically moving set of circles creates the impression that a planet will go forwards and forwards as time goes by. If we watch this, you'll notice that the planet is moving forwards, and then it reverses direction for a period of time, and then it goes back to moving forwards again, as all of this goes around the Earth. Again, a geocentric perspective. We call this epicyclic motion, epicyclic motion. Although this seems to work quite well, according to our understanding of physics of today, this is completely wrong. There's nothing physically accurate about this sort of movement. But you have to remember that the ancient Greeks did not have the luxury of modern physics to tell them when ideas were right and when ideas were wrong. The reason why this was so appealing to the ancient Greeks is because it matched what you see in the sky. It will properly explain the forwards and forwards, or the retrograde motion of any of the planets. And so, as incorrect as this may seem, as almost ridiculous as this may seem, this concept, this epicyclic motion, was considered to be correct. And it essentially was believed to be the explanation to describe the movements of planets, the workings of the universe, the accepted movement, and it was believed to be so for a period of nearly 2,000 years. It would take us 2,000 years to eventually correct this wrong notion and come up with the appropriate explanation of what's going on with our universe. So as you can see, an explanation that works, that is not scientifically accurate, but because there was no science, because the ancient Greeks were not using the methods of science, to them, all that was necessary was that they had an explanation that would mimic or match what they see in the sky. And it seemed good enough, it worked, and it was believed to be true. And it was held to this truth of this explanation of the universe. It was held to be true for about 2,000 years. And we'll find out eventually what is really going on, what the planets are actually doing. Even though you do see them go forwards and forwards, there is a better explanation, but it does not fit into this believed geocentric model. There has to be something that changes to correct this to the actual representation of what's going on. So that's all the time we have for today. What we'll do in the next segment is expand upon some of the other observations that you see in the sky, and we'll relate them to the geocentric model in an effort to try to further explain the universe, and then hopefully at some point to correct some of these mistakes into the basic understanding that we know and we appreciate today. I hope you'll join me.